Okay, in this lesson we're going to look at long division of polynomials. Now the reason we do this is simply so that we can find the x-intercepts of polynomials. Long dividing shows us the factors of a polynomial. If the long division is possible, then what we've divided by is a factor of the polynomial. And I'll demonstrate in a short minute, but first of all I'm going to go back over the long division algorithm, or the way we do long division. Some of you may not have been too familiar with this from primary school, so I'll quickly spend a few minutes now. In the example on the screen, we've got 274 divided by 13. Now the way long division works is we first of all take the 13 and see how many 13s go into 2, which we know to be 0. All right. Now the shortest way to do it is just to add those, or bring those two numbers together. So how many 13s are in 27? We know that the answer is 2. Now, you already know the algorithm for short division, but I'm going to show you long division. Long division calculates any remainder when that 13 goes into 27. And the way it works is as follows. So we take this 2 and we multiply by the 13. 2 times 13 is 26, and we write the answer underneath the 27. Oop, not 27, 26. There. All right, now, to find the remainder, clearly, we just subtract the 26 from the 27, and we are left with 1. Now the next step is to the 4, bring the 4, or drop the 4 down next to the 1, so that now we are working out how many 13s are in 14. And again, so we go 13 into 14 goes 1, and we don't need to calculate the remainder. Long division will do it for us, so we take the 1, and we multiply by the 13, we end up with 13. To find the remainder, we just subtract those two, we end up with 1. So therefore, we can write this as an answer. We can write that 274 divided by 13 equals 21, remainder 1. All right, another way of writing it is, not 1, is writing 21 and 1/13. We had 1 out of 13 left because we needed another 12 to get to a whole digit on the end of 21. Keep this particular format in mind, because this is going to be how or one of the forms we can use to write an answer when we do long division of a polynomial. Now there are a few terms I'm going to introduce to you which you should remember from primary school. One is that the number we are dividing is called the dividend. The number we are using to divide by is called the divisor. The answer, the whole answer, is called the quotient, and anything left over, which we remember is called the remainder. So that's how I'll refer to them from now on, and the book will refer to them as well. So just keep those in the back of your mind. Okay, so now we're going to look at a polynomial division. So we've got x squared plus 7x plus 11 divided by x minus 2. Now the first step is to look at the lead term, which is x squared. We're going to divide x squared by x, and we're going to write the answer not where you'd think it would go, which is above here. We're not going to put the answer into this spot here. All right, so x squared divided by x, we should be able to work out is just x. Now you notice that the answer has only got one x term, one power, which means that the answer goes above the matching term. So x squared divided by x, and the answer goes up there. All right. Now, to find the remainder, we're going to multiply back down, just like we did with the regular number in the previous example. So we have x times x gives us x squared, and we write that up underneath the matching term. Now you notice that in the divisor we have x minus 2, so we have to multiply the x by the minus 2 as well. All right, so x times minus 2 gives us minus 2x. Okay, now you notice that underneath each other are the matching terms, and this is a key for long division. You're going to need to make sure that everything in the column matches up with the correct power of x. Now, that's like we did in the previous example. We're going to subtract these from the top row, and you'll notice that I put brackets around them. This is because in the middle here at minus 2x, this minus 2x here, when I subtract it, that's going to become a positive, and I want to remember that I need to do that. Just like I showed you last lesson, you need to make sure that when you subtract a term, that it acts on all the things following it. All right, so writing underneath here, x squared take away x squared is going to be just 0. I'll put a little line here and we'll make 0. And then 7x plus 2x is going to be 9x. All right, now, the next thing we need to do is to bring down this 11 so that we've got a complete couple of terms to work with. All right, and just as before we take the lead term and we divide it by x, so the 9x divided by x becomes 9, and the 9 gets written above the term with the matching x power up above the 11. We notice that it's a plus, so we put a plus in there. All right, now we're going to multiply back down again, so it's going to become 9 times x is 9x, and 9 times minus 2 is minus 18. Okay, now the next step is to put a minus sign out the front of each of those and work down. Now what we're looking for here is that this 9x and this 9x are going to add down to become 0. So whenever you decide how to subtract this lead term, you're looking to make the answer a 0. All right, so 9x take 9x is 0, and then I've got 11, take away negative 18, which is going to become positive 18, so 11 plus 18 becomes 29. All right, now notice that there is no x term attached to this 29, which means that I cannot possibly divide it by x. So I've reached the point where 29 is now called my remainder. So what I can do is I can stop dividing there, stop dividing and start just writing the answer. So I can say, I'll write it all out in the full formula, x squared plus 7x plus 11 divided by x minus 2 equals, now the answer is above the line up here at x plus 9, so it equals x plus 9 remainder 29. Now remember, that was the one way of writing it. The other way of writing it was in fraction form, so you have x plus 9 plus, because the 29 was a positive, 29 over the divisor, x minus 2. All right, so you've divided the quadratic by the linear, and you've come up with a linear x plus 9 and a remainder of 29 over x minus 2. As you should remember from any primary school division or high school division, that if there is a remainder, it means that the divisor doesn't go evenly into the dividend. All right, now this is a key piece of information for us in methods, because it means that this x minus 2, if it doesn't go evenly into the dividend, it means that it's not a factor. And what we're looking for is a factor, because factors help us to graph or find the x-intercepts of these polynomials. So what we'd be looking for most especially is that x minus 2, when it goes into this dividend, that it leaves a remainder of 0. And the next example, I will show you one of those cases. In this example, I'm going to look at dividing x cubed plus x squared minus 14x minus 24 by x plus 2. I'm going to work reasonably quickly, and you can pause this video if you need to. So like before, I'm going to take the lead term and I'm going to divide it by the x. So x cubed divided by x becomes x squared, and I write the answer above the x squared terms. All right, now I'm going to multiply back down. So x squared times x becomes x cubed, and I write that underneath the x cubed terms. And I've got x squared times 2 becomes 2x squared. Now I'm going to subtract so that my lead terms become 0. X cubed take away x cubed is 0. And I'm going to go x squared take away 2x squared, because this minus and this plus produce a minus. So the answer there is going to be minus x squared. All right, now I'm going to drop this 14 or negative 14x down, so I'm working with 2 terms there. And now I'm going to take my lead term and again divide it by x. So x squared divided by x produces negative x, because it was negative x squared divided by x. And then I'm going to again multiply by both of those and write the answers underneath. So it becomes negative x squared, take away 2x. Now, you might notice here that I've got a minus x squared and a minus x squared. Don't worry about that, because when you subtract the 2, one of those is going to turn into a positive. All right, so minus x squared take away negative x squared produces effectively minus x squared plus x squared, which we should know is 0. Then I have minus 14x take away minus 2x, which is going to produce minus 14x plus 2x, which will be minus 12x. All right. Now, I need to drop the minus 24 down so that I'm always working with two numbers here. All right. Now, my next step is to take the x and see how many times it goes into 12x, which we should know is minus 12. Then I'm going to multiply that minus 12 back through. So minus 12 times x produces minus 12x, and minus 12 times positive 2 produces minus 24. Now again, you might get worried that you've got, or it's not going to work out, but again, when you put the negative through, it will all work. All right, so minus 12x plus 12x produces 0, minus 24 plus 24 also produces 0. All right, so here we've just discovered that the remainder equals 0. Now this means that the divisor of x plus 2 is, goes into the original polynomial. That means that it is a factor. So what we've just done is we've found a factor of this cubic polynomial. We've found one of the x-intercepts of this cubic polynomial. Now remembering your knowledge of quadratics and how it works, the factor of x plus 2 means that the x-intercept is where x equals minus 2. All right. Now, if I wanted to write this in partially factorized form, I could say that we have x plus 2 multiplied by, and what goes in this second set of brackets is the quadratic that was left over on top of the division symbol. All right. So it should be x squared take away x take away 12. So now I've gone and started factorizing the original cubic, all right, which we didn't really know how to do from the start. We knew how to do quadratics, but we didn't know how to do cubics, all right? And what that's done is that has now made the cubic more manageable. I've found a linear factor and I've got a quadratic factor as well. I can now look at this quadratic factor and I can say, well, hold on a second, I know what the factors of that are. So I rewrite the original x plus 2, that's already proven to be a factor. Now x squared minus x minus 12, factorizing by sight, should be factorizable into two linear factors as well. So suddenly I've taken my original cubic, and to find the x-intercepts I've started with long division to break it into a linear and a quadratic, and then I've taken the quadratic result and I've factorized that by sight. This means that I've now got 3 x-intercepts for my cubic. So this is the reason why long division is so important, especially or particularly for powers higher than 2, or cubics, quartics, and so on. All right? All right, I'm going to show you a less complex method, and the reason I'm showing you this at the end and not at the start, and I know you're all going to kick yourself when you realise that I'm doing a less complex method. The reason I'm showing you this is because you will need to know long division. Questions will ask you to use long division to produce a result. So don't rely on this short method. All right, I'm going to need you to know both. So this method is called synthetic division. And I've got an example of the long division for the same problem up in the top left corner. And I'm going to show you how to set up synthetic division. So synthetic division works off a little box or part of a box. In the top row, you write the coefficients of the original problem, which are from left to right, 2, 1, minus 5, and minus 3. And then down on the outside in the bottom, you write the divisor as x equals. So in this case, because we have x equals minus 3, the divisor is x equals 3. So I'm going to write that there. Now, the first one, all right? The first one just gets carried, so the 2 gets carried down to below the line. And we write it outside. So that's going to be the lead coefficient of the answer, as you can see in the top one there, in the example on the left. And if you notice in the example on the left, I've actually set it up wrong. The 2x squared should be in this position here, and everything should have been moved down 1. But look at the coefficient there, 2x squared, that's matching up with the red number outside the box here. Now the next step is to multiply the 3 by the 2 and write the answer here. So 3 times 2 is 6, and now we just add down. So 1 plus 6 is 7. And again, if you look on the example on the left, you'll see that the next term's coefficient is 7. All right, so this is working. So now we multiply again by 3, and we write the answer here. Now, add down, minus 5 plus 21 produces 16. And again, if you look at the example, you'll see that that's the next coefficient. And again, if you multiply by 3, 3 16s are 48. Add down, minus 3 plus 48 equals 45. Now, if you look at the example on the left, you'll see that 45 was the remainder. So then the next part of understanding about synthetic division is that you take these coefficients here that we've just found, and you're going to write them with their corresponding x terms. And it requires you to look back at the original polynomial and say, what was the first x term? Oh, it was x cubed. That means that when I've divided by a linear factor, the answer is going to, the lead term is going to have an x squared as the lead term. So I take the first coefficient and write it with an x next to it. The next coefficient is going to be plus 7, and I reduce the power by 1, 7x. The next coefficient, again, reduce the power by 1, is just 16, so the x disappears, and I have a remainder of 45. And again, if you recall the second way of writing this, we could say that it was 2x squared plus 7x plus 16 plus 45 over x minus 3. All right, so there's a little bit of different understanding that goes into this. We set it up a slightly different way. Key points to remember for synthetic division are that your divisor is the opposite of the x minus or x plus, whatever's listed, it has to be the opposite, and that you're only using the coefficients and then you add in vertical columns down.